Come with me if you want to live. Helpful assistants or Skynet-type machines destroying humanity? Which will large language models or LLMs become when they have grown up? To think about this question, it is helpful to first understand what LLMs are, how they are trained, and how the security mechanisms are already being breached today. Andrej Karpathy, a founding member of OpenAI, recently published an hour-long YouTube video on this topic called Intro to Large Language Models. Here is a less than 10-minute long summary for those who do not have the time to listen to Andrej's full video. This will help you understand why LLMs behave the way they behave. For example, sometimes providing an accurate answer, while in seemingly similar situations making a factually completely wrong statement with the same conviction as when they were right, or in other instances showing a certain bias in its answers. Let's get started. An LLM, once trained, essentially consists of two files. A very large parameter file, for example 140 gigabytes in the case of Meta's Llama 270B, containing the trained weights of the neural network, and a small runtime file written in a language like C or Python. The runtime file applies the parameters to a user input in order to produce the model output by predicting the next word in a sequence of words. But how are these parameters derived? The training consists of two main sequential steps, a pre-training step followed by a fine-tuning step. During the pre-training stage, the model is trained on a very large volume of internet text files, think 10 terabyte or 100 terabyte in size. This training data is large in volume but potentially low in quality, and leads to a representation of knowledge within the model. Once this pre-training step is completed, the LLM dreams web pages mimicking the training documents. And this explains the puzzling phenomenon that sometimes the answer is 100% accurate when the model has memorized the correct answer, while at other times the model ends up hallucinating even when asked a seemingly straightforward question like, who won the World Series in this or that year? The way an LLM is constructed to provide a next word prediction explains another strange behavior that LLMs of the past displayed called the reversal curse. In that case, the LLM could correctly answer the question, who is Tom Cruise's mother? The answer is Mary Lee Pfeiffer. But the model did not know the seemingly obvious answer to the question, who is Mary Lee Pfeiffer's son? Following the pre-training stage, the model is then further trained in the fine-tuning step. During this stage, the model digests a fairly small volume, think 100,000 documents, of this time high-quality documents providing answers to specific questions. This stage is not about enriching the knowledge of the model that happened during the pre-training stage, but about conditioning the model to act as an assistant, resulting in a bot that can answer users' questions. The documents used in the fine-tuning stage are created or evaluated by human labelers, also sometimes machine-assisted, specifically for this purpose. These labelers are people operating under instructions that typically instruct them to evaluate model output to ensure that it is helpful, truthful, and harmless. It is obvious that the judgment of whether an output is helpful, truthful, and harmless is highly subjective and has the potential to introduce major bias into a model. Lastly, and after giving an outlook into the future research and development of LLMs, Andrej Karpathy discussed attack vectors that have been used to breach the security mechanism of LLMs. It is probably fair to assume that most or all of the specific examples he gave no longer work with reasonably sophisticated LLMs. The examples are nevertheless extremely fascinating, as they are in their nature very similar to cybersecurity threats in conventional systems. These attack vectors include jailbreaking, where a user question that the LLM has been trained not to answer is disguised in a confusing story context or by converting the text code into base64 code. Another example is prompt injection, where a seemingly blank white image provided as input contains instruction in so light a font that it is not readable for human eyes, but is recognized by the LLM's image processing. In another instance of prompt injection, a website that is used as input contains hidden instructions that prompt the model to provide an entirely unexpected or even dangerous output. Where does this all leave us? Number one, LLMs contain a vast repository of knowledge, but have trouble knowing which facts they seem to remember are accurate facts versus hallucinations. Number 2, the chatbot-like question and answer capabilities of an LLM are generated through user-labeled content which can introduce bias into the system. Number 3, LLMs can be breached by attack vectors that can lead to unexpected or even malicious model behavior. So for now, LLMs are helpful even if sometimes imperfect assistants. However, there's a set of increasing abilities of LLMs that can bring LLMs, in my view, and I'm now not quoting Andre, closer to Skynet capabilities if not intention. These critical abilities include becoming more knowledgeable about a certain subject than any human, processing multimodal inputs and generating multimodal outputs, self-improving provided that a reward function can be constructed, communicating with other LLMs, and being deployed at the edge, meaning adjacent to effector outputs. Think your thermostat, your self-driving car, or someone's ballistic missile silo. I'll leave it at that. Thanks for watching.